Hello, this is Mr. Stansbury. I'm going to take you through the 11B assignment. All right, so we're starting with number 3 here. And it says to use P equals 4S for squares and P equals 2 times length plus width for rectangles to find the perimeters of the following figures. Honestly, I wouldn't use either of these. I would just use common sense. If you know that this is a square, because all the sides are all marked with the lines there, that means they're all the same, and this is a 3, I'm hopeful that you would just think, oh, 3 meters times 4 sides gives us 12 meters total for the perimeter, right? And then same thing here, if you're like, okay, this is 15, so this has to be 15, that's 8, so this has to be 8. So what they're trying to get at is if you just add these two together, so the perimeter is going to be 15 plus 8, which is what, 23, and you know you have that twice, so they say 23 times 2 gives us 46 centimeters total for the perimeter. Okay, for C, we got 1.5 plus 3, 3.6 is, let's see, 0.1, carry 3, 4, 5, that's 5.1. And then there's 2 of those because you got those also. So you go 5.1 times 2 gives us 10.2 meters for the perimeter on that one. All right? Okay, moving on. Number 5. Triathlon course has 3 legs. 1.2 kilometer swim, 8.3 bike, and 6.3 kilometer run. Okay, find the total distance around the track. So that's just going to be for A, we just have 1.2 plus 8.3 plus 6.3 will give us our total distance around the track, right? Around the course. So 1.2 plus 8.3 plus 6.3 gives us a total of 15.8 kilometers around the track. Okay. And then B, find the average speed of a contestant who took 1 hour and 10 minutes to complete the course. Okay, so let's see, you know that they did a total of 15.8 kilometers. So for B, let's do 15.8, and let's divide that by, it was 1 hour and 10 minutes, so that's kilometers, right? And then if we have 1 hour and 10 minutes, 1 hour and 10 minutes is the same thing as, let's see, that's 60 minutes plus another 10 minutes for a total of 70 minutes. So let's do this. Let's divide that by 70 minutes, and that's going to give us 15.8 divided by 70 gives us 0.2257, and that is kilometers per minute. Okay, now we usually don't want to figure stuff out in kilometers per minute. We want to figure it out in kilometers per hour. So if it's 0.2257 kilometers per minute, if we take that and we multiply those minutes by 60, this rate at 60, that would give us, that's going to end up giving us the speed in kilometers per hour. Okay, so let's just take our answer here, multiply it by 60, and we get 13.54 kilometers per hour is their speed that they went throughout the whole thing. Okay, there is another way to do it. You could turn the 10 minutes into hours. So let's just show that 15.8 kilometers divided by, and then we would take we have 1 hour and 10 minutes. So you could even take the 70 minutes divided by 60, and that would give us 70 divided by 60 gives us 1.1667. Okay, so we divide that by 1.1667, and that should also give us about 13.4, I'm hoping. So we can even leave that in there and just do 15.8 divided by our answer, which there's our 13.54 that way as well. 54 kilometers an hour. Okay, so either way, same thing. All right, moving on. Number 7. A tennis court has the dimensions below. Dimensions shown. What's the perimeter of the court? Find the total length of all the marked lines. Okay, so the total perimeter is just going to be, let's see, we've got 23.72. 0.72 is the length, and then the width is 8.23 plus the two 1.37s on the side for just the perimeter, right? So 23.72 plus 1.37 plus 1.37 plus 8.23, right? That's going to get us half. So if we take that whole thing and we double it, that will give us the total perimeter, right? So let's calculate that out. So let's do the inside first. 23.72 plus 1.37. We've got two of those, so let's just do 1.37 times 2 plus 8.23 gives us a total of 34.69. 34.69, and again we just got to double that, so multiply that by 2 and we get 69.38. 69.38 meters for the total perimeter. Okay, find the total length of all the marked lines. Well, let's see, we've figured out what the and let's do this in red. We've figured out the total perimeter. So we've figured out all the red marked lines already. Let's figure out the rest of them. And the net, this big dark line here is the net. That does not require a line. So we need to add on 2 more. So we got to add on the perimeter. So we do the perimeter plus 2 of these 23.72, so 2 times 23.72 plus, let's see, we've got 2 of these, which is 8.23, so 2 of the 8.23 meter lengths, plus we've got 2 of these 6.4, so plus 2 of the 6.4 meter lengths there, and I think that, yep, that covers everything for us. So let's calculate that out and see what we get. So we got 69.38 plus 2 times 23.72 plus 2 of the 8.23s plus 2 of the 6.40s, or it's just 6.4s. And that gives us 146.08. And this is part B, right? So 146.08 meters of total lines that need to be marked. All right, let's move on to the next one. Number 9, farmer wanted to fence his private garden to keep out wandering cattle. The garden measured 26 meters by 40 meters, and the fence had 5 strands of wire, and posts were placed every 2 meters. Calculate the perimeter. So part A should not be too bad. The perimeter is, if it's 26 by 40, the perimeter is just going to equal 2 of the 26 lengths plus the 40 lengths, right? So that's going to get us 2 times, let's see, 26 plus 40, right? Yep. So that's going to be 132 meters total for the perimeter. Okay. For B, what length of wire was needed? So that's the perimeter, and all of the perimeter had 5 strands total, so we're just going to do 132 times 5, right? So we just take our 132, multiply that by 5, and we get 660 So we need 660 meters of wire. Okay. How many posts were needed? So that's kind of the tricky part. So if we look at this here, so here's our 26 and here's our 40, right? We got 26 by 40. So if the posts have to go every 2 meters, it would make sense that you would take 40 divided by 2, and that gives us that there are 20. That breaks it into 22-foot pieces. Right? Now, problem is you've got 20 2-foot pieces, right? So that's going to end up giving us, there's 20 total stakes all along this line, and then there's also going to be 20 along here, right? But if you think about here, let's do this. Here's our fence. We're looking at like ground level. So we got the first one here, and then the second post goes in at 2 meters later, right? So there's actually 2 posts that we need just for the first 2 meters, and then another 2 meters here, all the way up to the last 2 meters. So you actually are going to have 20 plus 1 post extra on each to get each piece here on the end. Okay. So actually from here to here you'll end up getting 21 posts. There's 21 posts here, 21 posts there. And then if you take 26 and divide that by 2, we get 13. So we've got 13 from here to here plus 1. So that's 13 plus 1. But these 4 end posts, that's 13 plus 1 here. These 4 end posts got counted twice. So we end up, I know you may think I'm causing you grief here, but we end up getting rid of, we've counted 4 extra posts, so we got to get rid of all those plus 1s at the end. So then it does just end up being 2 times 20 plus 13, so that's what, 33 times 2, which is 66 total posts, right? So that's 66 posts. And then, sorry, back up here we had 132 meters of wire and 132 meters is the perimeter, 660 meters of wire, right? Okay, let's figure out D, the last part here. Find the total cost of the fence if the wire was 28 cents per meter and each post was $3.95. So for D, we've got the wire is 28 cents per meter, so we have 660 total meters of wire times 0.28, and then we have to add on all the posts, right? So we've got 66 posts times $3.95 per post. Okay, so we just got to go through and calculate that out, and that'll be our total cost of the fence, of putting up a fence with the wires and the posts and all that. Okay, 660 times 0.28 plus 66 times 3.95 gives us a total of $445.50. Okay, so that's not too bad for a big 40 by 26 pen, about $500 to make that. Not too shabby. Anyway, moving on to the next one, number 10. The old back fence is to be replaced by a wooden paling fence. The fence is to be 1.5 meters high and 51 meters long. Posts are 3 meters apart, and there are 2 railings the length of the fence. Use the following table to calculate the cost of the wood for the total fence. Okay. So basically, we just got a big, long fence. Okay, it's 51 meters long. Posts are 3 meters apart. So let's figure out the posts. So post is you take 51 meters and divide it by 3, and that is going to get us, we got 17, isn't it? Let's see. 51 divided by 3 gives us 17. Okay. Now, you have to figure out that that's 17 3-foot lengths, 3-meter lengths, right? So the problem is you're going to have these 17 lengths. So let's say you start here, there's your first one, there's a 3-meter length, and then there's your second one, 3-meter length. You do that all the way along until you get to the last one. Here's one here, and then the last one's going to take another 3-meter length. So you're going to have 17 is going to take you right to here, because you start with one and then you go 3 and then you put another one up. So that's going to take you to here. So you have to add one more. So we're going to have 17 plus 1 for a total of 18 posts. Okay, that's going to be the tricky part. It's not just, you can't just divide it by 3. There's 17 3-foot sections, but you need a post at the beginning and at the end. So you have to add one post on to get to the, like, say, the end part. Okay. Let's see. There are 2 railings the length of the fence. Okay. Let's see. Size per unit for the post. Well, we know we need 18 posts. So we have 18 times $3.85 is going to be the total cost for the posts. Okay, we'll figure that out in a little bit. The railings are 75 millimeters by 50 millimeters, and they're $2.20 per meter. Okay, so if we have a total of 51 meters that we need, then we just need to take our, let's do posts here in, the railings in red. So we got to take our 51 total meters, right? We don't have to divide it, but we have 51 total meters that we're going to need, right? So we're just going to need to do 51 times $2.20, right? Because that's the railing. Oh, except for we have 2 of those, so let's do 2 times 51, because there's 2 railings the length of the fence. Okay, and then the palings, I would imagine that's going to be the fence boards that go up and down. Excuse me. It's 1.5 meters high, but it just says it's $1.90 per paling, so we have to assume that it's at least 1.5 meters tall, right? So we have 150 millimeters wide. So what we need to do with that is we have 51 total meters to cover. Okay, now each paling covers 150 millimeters, so let's turn the 51 meters into millimeters, right? So meters to millimeters is over 3 spots, 1, 2, 3, so that's 51,000 millimeters that we need to cover. So if we take our 51,000 total millimeters and divide it by 150 millimeters per board, that'll tell us how many boards we need, right? Or they call it a paling. Okay, so let's do 51,000 divided by 150, and that gives us 340 total boards, right? So we've got 340 times $1.90. Okay, so let's go through and calculate all of these. We got 18 times 3.85 is 69.30. Okay, and then for the excuse me, the railings, we've got 2 sets of railings at 51 feet. And those are all $2.20 per meter, so that's going to be $224.40. Right, and then we've got our palings, the fence boards, so that's going to be 340 times $1.90 for each of those, and that's going to be $646. just for the boards. Okay, so we add those all up. We get, so let's see, 646 plus 6930 plus 224.40, and we get 939.70. Okay, so that's how much it's going to cost for that, to make that entire new back fence. Okay, let's take a look at the next one then. Okay, number 11, a room has a shape and dimensions shown. Skirting board is laid around the edge of the room. How much skirting board would be needed? This one always throws people off a lot, but if you think about it, if you take this piece right here and you move it across and put it right there, and you take this piece here and move it across, put it right there, so now this is gone and this is gone, and you do the same thing with these here, so that moves over to there, this moves over to there, and now these are gone. Then guess what you have left? You have a rectangle. Okay, so for A, it's just going to be twice 1.4 plus 2.5 for this side, so you got two of those, and then you also have 4.2 plus 2 for this side, and you've got the second one for this side. So we add these all up and then we double it because we've got two of those. Okay, so let's figure out what that gives us. So we got, let's just do the inside, then we'll multiply our answer by 2. 1.4 plus 2.5 plus 4.2 plus 2 gives us 10.1. Multiply that by 2 and we get 20.2. 20.2 meters of skirting board needed. Skirting comes in 2.4 meter lengths, which can be cut. If each length costs $2.48, what is the cost of the skirting board? So we need 20.2 meters, and it comes in 2.4 meter lengths. So we just need to take, for B, we need to take 20.2 and divide it by 2.4 to figure out how many boards we need, right? So 20.2 divided by 2.4 gives us 8.417. Okay, so it's asking, it comes in 2.4 meter lengths. Guess what? You need 8.4 of those lengths, but they're not going to let you just buy 0.417 of one of those boards. So what this means is you have to buy, we need to buy 9 of those. We need to buy 9 boards, right? Because they're not going to sell you just a half of a board. That's not the way they work. So we just need to do 9 times 2.48, and that'll give us the total cost of all the skirting boards. 9 times 2.48 gives us 22.32. And the nice part about that is you'll have a little bit of extra left over in case you make some bad cuts or you mess stuff up. Okay? Okay, let's move on to the next one then. Number 2, find 3 significant figures, the perimeter of each of these here. Okay, so perimeter is on this one here. This is obviously 10. So that makes this radius here 5 centimeters, right? So from our formulas here, we know that the circumference of a circle is going to be 2 times pi times r. Okay, so for the circumference on this one here, we've got 10 centimeters, this part right here, plus we have a half of a circle, so that's going to be 2 times pi times r, but we only need half of that, right? So we'll do 10 plus 2 times pi. In this case, the radius is 5, all divided by 2, right? So those 2's basically go away, and it's going to be 10 plus 5 pi. So let's figure out what that is. 10 plus 5 times our pi button, and that gives us 25.707. So we'll go with 25.7. Let's see. Yep, because we already added the 10 in. 25.7 centimeters for our perimeter on that. All right, B. We have this and this, so that's 7 and 7. So we've got 7 plus 7 plus this in here does not count, but it's 3 centimeters for the radius. So again, we've got half of our circumference on that one. So we've got 2 times pi times our radius, which is 3, right? But again, we only need half of that because we just have half of a circle. So it's going to be 14 plus 3 times pi. So let's figure out what that is. Okay, so we got 14 plus 3 pi, and that gives us 23.4. So we get the circumference is 23.4 centimeters on that one. Okay, this one here, we've got this length here and this length here, which are both 6 meters, right? So we've got the perimeter is going to be 6 plus 6 plus our 2 half circles. So 2 half circles actually just make 1 circle. Okay, so that's just going to be 2 times pi times the radius. Now, here's the thing here. So see how this line, this line, this line, and this line, that means that these are also 6 meters because they're saying that this is basically a square with a 2 semicircles patched on. So if this is 6 meters, then this radius is going to be 3 meters as well. So that's going to be 2 times pi times 3. Okay, so the perimeter on this is going to be 12 plus 6 pi. So let's calculate what that is. 12 plus 6 pi gives us 30.849, so we'll go with 30.8. 30.8 meters on C. Okay? All right, let's move on to the next one. Number 3, how far did I live from school if my bike wheel had a diameter of 32 centimeters and the number of revolutions made by my wheel from home to school was 239? So really what we've got going on here, you've got your bike wheel here, okay? So the diameter is 32 centimeters, right? So again, we know that the circumference of a tire is, or circumference of a circle is 2 times pi times r, right? So what we need to do to figure out is the radius. So that's going to be 32 divided by 2 is 16. So from here to here is 16 centimeters. So let's figure out the total distance covered by 1 full revolution of the tire. So we get circumference equals 2 times pi times 16, right? So let's calculate that out. We got 2 times pi times 16 gives us 100.53. So the circumference equals 100.53 centimeters. So every time it spins, you get 100.53 centimeters. Okay, now it says that it made 239 revolutions. So let's take 100.53 and multiply that by the 239 revolutions and see what we get for the total distance. Oops, I should have left that on there. Yep, there's that. And then now multiply that by 239. Gives us 24026.9. 0.9, and that's centimeters. So that's kind of not a real handy measurement, centimeters. So let's turn it into meters. So remember, King Henry died unexpectedly drinking chocolate milk. So centimeters back to meters is 2 back to the left. 1, 2. So 240 point, let's call that 0.27 meters. All right, so that's, you only live 240 meters from school, so that's not very far. Not too shabby. All right, last one. All right, that is number 4. Ooh, yeah, this is a good one. A lawn is basically a rectangular with 2 meter radius quarter circles removed from each of its corners. Bricks of length 220 millimeters each, costing $1.70, are used to border the lawn. A, find the perimeter of the lawn. So let's see, we know that this is like this rectangular piece here is 16 by 10, but we've got these little 2 meter pieces cut out here. So basically, if you want to know from here to here, you got to subtract 2 meters here, and you got to subtract 2 meters here, just like what you would have to do for these here. You'd have to subtract 2 meters here and 2 meters here just to find these lengths here, right? So that's going to be 16 minus 2 times 2 is 4. Okay, plus we got to add in the 10 minus those 2 sets of 2 meters each. So 10 minus 4 is going to give us these here. But then we have to take all that and we have to multiply it by 2 so that we get this and this in there as well. Okay, so let's see, 16 minus 4 is 12 plus 6 times 2. So 12 plus 6 is 18 times 2 is 36. So we got 36 meters of the straight, all those blue lines there. Okay, now we have to figure out all these curvy spots here, right? So look, if you take this, 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 and this, and you put them all together, guess what you get? You get a circle, because there's 1 quarter, there's another quarter, there's another quarter, and there's another quarter. So you end up getting a full circle. And we know that the radius of this circle is 2 meters. So circumference on that thing is going to be 2 times pi times the radius, which we now know is 2. So the circumference is just going to be 4 pi, whatever that is. Let's figure that out. 4 times pi gives us 12.56. So let's go 12.6. 12.6 meters. So the total circumference is going to be 36 plus 12.6, which gives us 48.6 meters for the circumference of this whole lawn. Okay? Okay, so part B, how many bricks are necessary to border the lawn? Allow 2% for wastage. Okay, so basically what we need to do is we need to figure out how many bricks we're going to need, but then we need to add an extra 2% to that, right? So 48.6 is the total meters around, and then bricks of length, oops, I was supposed to underline, but I crossed it out, 220 millimeters each. So this is 48.6 meters. Let's do this. Let's turn that into millimeters. Right? So 48.6. So King Henry died unexpectedly drinking chocolate milk. Right? So from meters to millimeters, 1, 2, 3 spots to the right. 1, 2, 3. So that's 48600, 48,600 millimeters that we need to cover. So we take that 48,600 divided by 220 to figure out how many total bricks we need, right? So let's figure that out. 48,600 divided by 220 gives us 220.9. So let's call that 221. But again, remember we need to have allowed 2% for wastage. So we got to take that 221 times 102%. We need 102% of that. So 102 as a decimal is 1.02. So let's do this. Multiply that by 1.02, and we get 225.3. So we need 226 bricks if we're allowing for 2% wastage. Okay? Find the total cost of the bricks. Sorry, that was B. So finding the total cost of the bricks is C. Each brick costs $1.70. So really all we have to do is take 226 times 170, and that's going to be the total cost that we're going to need, right? So 226 times 170, and that gives us 384.20. So $384.20 to put bricks all the way around your lovely lawn. Okay. Okay, moving on to number 5. 5A, find the diameter of a circular pond of perimeter 37.38 meters. Okay, so what we got to do here is we got to we already know what the perimeter is, and we know it's a circle, so we would just use our perimeter formula. So perimeter equals, let's see, what is it, pi, well, 2 pi r, right? So, or perimeter also equals pi times the diameter, because since they're asking for the diameter, let's just use this one here, right? So perimeter is 37.38, and that equals pi times our diameter. All right, so basically we just need to divide both sides by pi, and we will figure out what our diameter equals. All right, so let's see, let's bust out our calculator here again. All right, and let's see, so we got 37.38 divided by pi, and we get 11.898, so let's go with 11.90, and that's going to be meters. Okay? Okay, for B, we've got the radius of a circular pond whose perimeter is 32.67. So now we're just looking for radius. So let's use perimeter equals 2 times pi times r. So our perimeter is 32.67, and that equals 2 pi r. So we want to divide by 2 pi, right, to get rid of those. So let's see, we will clear that out and do 32.67. And you can either do divide by pi and divide by 2 to get the right answer, or you can do divide by parentheses pi times 2. Either way, we'll get 5.199. So let's go with 5.20 is our radius, and that is in meters as well. Okay. All right, last one, number 6. An athletics track is to have a perimeter of 400 meters and straights of length 100 meters. Find the radius of the bend of the curvy part. Okay, so if we know that the perimeter of this whole thing is 400 meters, we know that this is 100, we know that this is 100, so we know if we take these two rounded parts, the two bends here, and put them together to form ourselves a circle, which that does not look like a circle, but you get the idea. So this and this together, we will put together to make a circle, and we know that that perimeter, since we've used 2 of the 400 up here on the straightaways, this would just be 400 minus 200, which is 200 is going to be the perimeter of this thing here. So perimeter is, and we're looking for the radius, so perimeter is 2 times pi times r. Okay, so we know the perimeter is 200. 2 times pi times r. So we want to divide both sides by 2 pi. And that will tell us what our radius is. So let's do 200 divided by 2 and divided by pi. Okay, and we get 31.83. Let's go with 31.8 meters should be the radius of the bend. Okay, All right, that's all there is for this here. If you have any other further questions, please feel free to ask in class. Thanks.